Hello students and welcome to this video. So what are we doing here? We are practicing past paper practice questions on the topic moments. This is our third question, the third video. Please pause the video, attempt the question yourself and then play the video again to look at the working of it. And as I always say, the questions on moments are usually easy. Whenever the question on moment will come in your question paper, you should get relaxed and be happy because this is an easy topic. And as we practice more and more questions on this topic, you'll understand that it is not a very complicated topic. Even question number 1 and 2 were quite straightforward. Same thing with question number 3. So I believe that you have solved the question and you are back. So let us understand what is happening here. Define the torque of a couple. So the first statement starts with just asking for the definition of the couple. It's a 2-mark question. So maybe they are looking for 2 tiny points in your definition. So how do you define torque? You can write straight away the formula, right? But do not miss on the key term, which is perpendicular distance between the force. Torque is the product of one of the forces and the distance between forces. If you are just writing distance between forces, you get just 1 mark. Right? So understand what the mark scheme is saying. If you're writing this, it is the product of one of the forces and distance between the forces, 1 mark. If you are including the perpendicular distance in your answer, perpendicular is a key term, then you get 2 marks. So be careful. That's why practicing past paper questions by looking at the mark scheme is very, very important. Pay attention to the mark scheme. Perpendicular is underlined. That means it is a key term and very, very important. B part. Now you're given a situation here. Let us understand what is happening. A uniform rod of length, total length 1.5 meters and weight 2.4 newtons is shown in this figure. The rod is supported on a pin passing through a hole in its center. You see the pin here. The ropes A and B provide equal and opposite force of 8 newtons. Equal and opposite force. It is a situation of creating a torque, which is a situation of creating a circular turning, right? Calculate the torque of the rod produced by the ropes A and B. Easy question. The formula that you mentioned here, it has to be applied here. So what will be the torque? Torque would be equal to one of the forces, which is 8, multiplied by the perpendicular distance. Perpendicular distance is also mentioned here. You need not do any calculation to find the perpendicular distance. Very, very straightforward question. Right? So it comes out to be 12 Newton meters. It's a 1 mark question. Why? Because it is easy. Let us tally our answer with the mark scheme. Yes. Same thing. Alright. Now discuss briefly whether the rod is in equilibrium. Now there are 2 conditions required for an object to be in equilibrium. What are the 2 conditions? Resultant force should be equal to 0 and the resultant or the net moment should also be equal to 0, and both the conditions should fulfill. If you look carefully, the rod is turning ultimately. Turning means there is a moment, there is a turning happening, so resultant moment is clearly not equal to 0, and the total resultant moment also you have calculated here, it is 12, not 0. So therefore you can say it is not in equilibrium. So the theory about finding if an object is in equilibrium or not is very well explained in one of my theory videos. The link for it is in the description box. Please check it out to understand, go through the theory of determining if an object is in equilibrium or not. So this is a question which extends to the second screen as well. Times the distance of B from the point P. So how much is it? Half the distance is how much? 0.75 plus 0.45. So how much it becomes? 0.45. So 5 and 5, 10, 1, 12, 1.2, 1.2. Now solve this equation for the variable b, which is very straightforward. All you need to do is do some calculations. So it goes 2 times here, 2, so the 0.9. So the tension is 0.9 newtons. Let us tally our answer with the mark scheme as well. Yes, easy question. Alright, so calculate the tension in the rope A, 1 mark question, so it should give you a hint that it should not a difficult question. Since the entire situation, entire thing that you see system, this entire system is in equilibrium, the resultant force should be 0. That means all the upward force, which is tension in A plus tension in B, should be equal to all the downward force. A plus B are the upward force, should be equal and opposite to the downward force. So how much is the tension in A? Weight minus 2.4 minus tension B, 0.9. So how much it becomes? 5, 14 minus 1, so 1.5. Let us tally our answers. Yes. Or you can also solve this question by using the principle of moments. There is one way of also solving this question. If you are solving that question in that particular way, please do share it in the comment box. Let me know your other way. I know that there is a way. I would like to see if you can catch that other way of solving and finding the tension in the rope A. That would be using the principle of moments as we calculated B. Then we'll have to take the turning effect around this end. I'm giving you some hint as well. Turning effect around this end, which makes this moment 0, right? Or you can take the turning effect around any other point around the weight as well. Makes sense, because you have now just one variable left, one missing quantity left to find out. So you can take turning effect around weight or around this end. Everything will make perfect sense. Alright, so this was your question, third question on moment. Here is the mark scheme. I'm going to open it so that you can have a look at it, read it and understand it very well. So wasn't the question easy? Yes, it is an easy topic, believe me. So practice it. Do not let this topic go from your hand. It is an easy to score topic, and I'm sure you can do very well in this topic. So stay tuned and stay connected for the next video, which will be question number 4 on moments.